So this is my AP problem number 5. So the question that we're given is right at the top. It's numbered 3. And we're also given the chemical equation. So the first question I had to answer was part A, and that's we're given a 25 milliliter sample of 0.25 molarity NaCl, and that's reacting completely with excess KMnO4. The Cl2 produced is dried and stored in a sealed container, and at 22 degrees Celsius the pressure of the Cl2 in the container is 0.950 atm. So for the first part we had to calculate the number of moles of Cl- present before any reaction occurs. So at the top here, this is my calculation. So for the moles of Cl-, I did molarity times liters to get moles from the molarity in liters given in the first equation, and I got 6.25 times 10 to the negative 3 moles of Cl-. And part 2 is asking to calculate the volume in liters of the Cl2 in the sealed container. So I wasn't able to do liters right away, so I first did moles. And I got that from doing a mole-to-mole ratio of getting that from part 1. And so I did the 6.25 times 10 to the negative 3 times the mole-to-mole ratio that were given in the chemical equation. And I got that the moles of Cl2 was 3.125 times 10 to the negative 3. And then I plugged that into a modified version of PV equals nRT to get the volume in liters. So I plugged in all the values that were given in the equation, and I got that there was 0.0797 liters of Cl2. In part B, we're given this table right here, and then using the information in the table, we had to determine the order of the reaction with respect to two different things. So the first one was in respect to Cl-. So I compared experiment 2 and experiment 1, and after plugging in all the values I got the exponent to be 2, so in respect to that it's second order. And for part 2 we had to find MnO4-, so I compared experiment 2 again with experiment 3, and I got the exponent to be 1, so it was a first order. And then in part C, it says the reaction is known to be third order with respect to H+, and using that information and the answers from part B, we had to complete two different things. And the first thing was writing the rate law for the reaction. So the rate law is K times Cl- squared times MnO4- times H+ to the third. And then for part 2, we had to calculate the value of the rate constant K for the reaction, including appropriate units. So I used trial 1 from the data table. So I plugged in the values into the rate law, and I used the rate given in trial 1, and I got that the K value is 1.93 times 10 to the negative 3. Molarity to the negative 5 because there's 5 molarities, and then S to the negative 1. For part D, it asks if it's likely that the reaction occurs in a single elementary step, and we had to justify. So I said no, because the orders of the reaction with respect to the reactants are not corresponding with the coefficients like a elementary step should have corresponding coefficients to the order, so the answer is no to the last part of that AP question, and that's the end of my AP problem.